and thanks for the opportunity to come sing you karaoke here in Norway. Never done this before, never had this kind of microphone singing karaoke, so I feel like a bigger star. Okay, let's get started. So, first, very shortly about Geomachine company, what we do, where we come from, and a little bit about PTO, and then going more to the geothermal side. So it turns to be 40 years old company this year, mainly operating in Scandinavia, also some rigs to Canada. Russia used to be the market, but no longer. And really the product range has been more in the soil research, in the geotechnical drilling. And also Geomachine has manufactured few, let's say, traditional geothermal rigs to the 400 meters deep and so. And where we come to this deeper geothermal drilling, we call it semi-deep. So we are drilling about 2 kilometers deep holes with our drill rigs. So we come from a different angle. So most of the discussions today have been about how to come from the oil and gas industry to geothermal. And in Finland, I just checked, there's about 10,000 geothermal wells drilled each year. And normally it's been raising, so it used to be 10 years ago 200 meters, now I think the average is about 300 meters or even more. And many companies are now targeting to deeper, and we had to, probably we saw this Espoo exercise with ST1, they tried to go to the 7 kilometers, and actually the drill rig is kind of developed based on those experiences, and we saw earlier that the cost curve really, it's not linear, so deeper you go, the higher the cost curve goes. So our customer and our thinking now is that maybe the sweet spot is there between 1.5 kilometers, 2.5 kilometers. And our drill rig and the whole development of the machine has been really to single-purpose rig, to geothermal. Well, it used to be the single-purpose. I will show some other applications now that has come up to this, but really to develop a machine that will be cost-effective, that can really be used in the contractors, so that it doesn't need external funding or anything, so that it would be a commercial machine and it would be the, let's say, the best and a most efficient way to produce energy from the ground. Then Robin here, he's our partner in Norway. Do you want to say something more? So, what we do traditionally, and what is the main business, it's been here. And we have tens of rigs in Norway, tens in Sweden. Last year we delivered 7 only to Norway to the geotechnical investigations. We have some geological core drilling rigs, not too deep, only to about 500 meters with our rigs. So they are just kind of same that geotechnical, but the core drilling equipment. And we have done this traditional 400-meter geothermal rigs, but now we've started new development about 3-4 years ago, and we thought that, okay, let's not go to this market, which is the most competitive. We have all the Italians, we have lots of competition, we have the Norwegian companies that let's target to go deeper than 1 kilometer. You can find rigs to the 800 meters, 1,000 meters, but there really isn't. And then you have these big oil and gas rigs, which are too expensive. No, I don't know if they are too expensive, but they are in a different size class. So they come from the different angle to the topic. And another thing what we are very much been developing is digital services. So because in the geotechnical research, the output of our rigs is the information. So when you do geotechnical research, you get no value add for the hole itself. So you are only drilling for the information that the hole provides. And therefore, we are very advanced on collecting all the information related to the drilling process. So we gather information for the rig, how it's operating, and we gather information, all the torques, weight on bits, we have the speeds, and we make the analysis on what kind of ground you are when you are drilling. Because that's the history and that's the kind of role of these rigs. And now we are bringing that technology also here. So that all the time that you drill, you get the measurement data. I know in oil and gas we saw the old rig, of course there is also good measurement systems. But if you look at the traditional geothermal well drilling rigs, they are very manual. They are still with the sticks you need to control. You don't get any information. The drillers, they kind of feel it. They touch the machine that, okay, now I need to do something. So there is no advanced digital systems. So what we are now bringing is to bring really here for the information capability to the geothermal and also take the geothermal rigs to the depth of 1.5 kilometers, 2 kilometers. And rest is more about this GM2000. So this is the now only product for the geothermal we are doing. So we actually quit manufacturing GM400, which used to be the normal rig, and this is what we are kind of putting our bet on. And just about the market needs, why we decided to go this is really because we see that the geothermal is the future, and really we see, I think maybe the last one was one of the main drivers, that instead of drilling 60 holes to a new area, you can drill 1 or 2 holes. There really isn't area in the places where you need to get the geothermal energy. And I have some calculations here based on our customers' calculations that you can really replace, we talk 300 meters wells, you can actually get the same energy amount from 1 hole that you would get from the 60 traditional holes. And also now that we had the rig, we have been trying to market it quite actively. Then we have started receiving actually contact from different companies for a little bit different applications. So we started only for geothermal. Now we have a couple of projects starting or offering phase that you should use the deep holes as carbon sinks. Then there's one for hydrogen storage, and also there's one project starting for the lithium extraction. They all kind of need to go in a hard rock to the 1.5 to 2.5 kilometer deep. And really, we were discussing about the rock type. We do it in the hard rock. So this rig is designed for the drilling in the bedrock. So the holes we have in Finland, you normally have few meters soil before you hit the bedrock. So it's rock drilling, and therefore it's a DTH. Because with the DTH, you can go 20 meters per hour. So if you go to the conventional system, it's totally different case. We have some more measurement data how much you really progress with the DTH hammer. And the workforce thing. So if you operate these, let's say, traditional drill rigs that are designed to drill to a few kilometers deep, you probably need 5-6 people. I know here we have this automated drilling, but still I believe we need some crew to operate it. But this machine, the whole setup is designed that it's from 2 to 3 people to operate it. So it's less workforce will be available, and also you need to do it, let's say, in the faster space, faster and in the smaller space what you're doing. And then about the technology, or let's say the main thing, what we think is the cost of the drilling. This needs to be profitable for our customer. So you need to be able to take the deep, or not deep, the semi-deep drilling to the level that really it has the business case, so that it doesn't require additional funding, and it can be commercially profitable. So far it hasn't been. So the holes drilled with this machine and previous exercises in Finland, what have been that they have been huge investment and not so good results. With this rig now, in half years, we have done over 2 kilometer holes, and the last one was less than 2 months, if you count the drilling time. There was some problem with the grouting, but if you count the drilling time. So the really purpose is to make it to the profitable level. I put some calculation, and actually the operational drilling time to go to 2 kilometers deep, it's about 200 hours, and if you count how it goes, it's more time that you need to change the drill rods than what you do actually drilling. If you can do this 0.5 meter per minute, what is the current what we have been measuring about the drilling speed with the DTH hammer. And therefore, making the rod changes faster and getting better rock bits. That's the, let's say, the drilling itself, it goes fast with the hammer, but if we can make the changing of bit faster, and if we can get bits that don't wear so much, we can really win the big time. And even now we tried, or the customer tried with this diamond-coated rock bits, they were able to double the amount. Now they are changing the bit every 200 meters, but they were able to do it 400 meters with the one bit now. So it's DTH, down the whole hammer, so it's an air hammer hitting down on the next to the rock. We have 9 meter drill rods. We have 60 ton lifting capacity, meaning that we can go with 140 drill pipes. And the weight on bit control, which is kind of new in the DTH space, or which the, let's say, old hydraulic systems without the digital operator don't have. So this is the key also, because as we were discussing, the deeper you go, the risks gets much higher. So the process needs to be controlled. If you are in 1 kilometer and you lose the bit there, you lose the whole, it's a huge loss. If you do 400 meter wells, if you lose one, next day you start another one and you just kind of dump it there. You don't lose so much money on that. So it's really important that we have torque, we have the weight, we have the forces all in control, and you really can see what is happening down there on the hole, or you can see it from the, let's say, measurements, that what's happening, how the process is going. Another thing, short setup time. So this is not something you build. You drive it to the place, there's a self-erection, it actually stabilizes itself, and you can start drilling. So it's nothing to build. You can move it with the trailer to the next place and start drilling in the next place. So that's also a driver for that. And yeah, I have it here also, the downtime. So actually the drilling time, or even the change in the rod time, that's not the big thing. The time goes to everything else, all the hassle, everything doing with the machines, with the compressors, or whatever there is. So a little bit about the overall system. So we have here the GM2000, which is a drill rig, and it's a DTH hammer system, so it requires a lot of air, because you know the air in a traditional wells, 400 wells, you need to have only one 35 bar compressor. When you go to 2 kilometers, you need 2 or 3, and then we are not sure if we need the compressor. Currently, customer has the compressor, but they were able to go to 1.8 kilometers without any booster, so just adding the airflow. So 2 to 3 compressors and a booster, what is the current setup. And then when we talk about automated drilling, now we can control pretty nicely the drill rig, so it can adjust, keep the weight on bit stable, keep the torque stable. If something happens, it kind of helps. You don't need to do it yourself. But then also, of course, we should be next phase trying to integrate the air control to the same system, that how much flow you have, how much you have cuttings coming out, and so on. So it's not currently in the same, but we can follow it up from the pad, but it's not controlled in the same system yet. How much time I have? So I think I more or less talk about this. So this is our vision. So it's about the same vision what we had here, the automated drilling, so that we want to make the driller, now the driller in the geothermal, he's actually, or she's actually putting these 30 kilogram drill rods and changing and doing it manually. So our vision is really that the driller would be process control, like you are working in the paper factory or something. You see everything what's happening. Okay, if you need to do, you do something, but you don't need to do everything manually. So that's the kind of, and also, therefore, you can teach the next drillers. It doesn't require 5 years to be on the side of the hole to kind of see what's happening, so that we want to have the data coming from the system, and we want to make the role of the driller really to start managing the process, not doing all the manual work him or herself. And this is the other part I said, because we have done a lot of development on the measuring what's happening on the hole, because the geotechnical background, because that used to be our only product, that we produce information from the hole. So now we're putting just kind of the, not exactly all the same technology, but with a little bit adjusting to this one, because now we are doing with the down-the-hole hammer. Of course, it's a bit more difficult because we are hitting all the time. So you don't get all the information we get in the geotechnical side. But there is also development going on now, getting some measurement from the hammer. And so maybe just last one, the easy mobilization. So I think this is also key, that you need to be able to move it easily. It can't require huge area where to drill, and so easy to set up and easy to use.
Thank you very much, Samuli. I guess we see the potential synergies here between the two, oil and gas and geothermal.
We come from fields. The small size, and they come from the big size.
Yeah, but the interests and the topics are really similar. Any questions from the audience? Yes, please, Malte.
Yes, for these 2-kilometer wells, what kind of heat exchanger do they use? Is it normally just U-tube, or?
You know the collector pipes? They have actually Q-heat, they have their own design, but it's quite similar we saw in this previous setup. So it's a closed loop one. So it's a coax inner tube and outer tube.
Okay.
And it's what we saw there. Yeah.
Yes, please.
For the data, as you say, you post or you collect and analyze, is that, do you have downhole information as well, sensors, or is it surface sensors?
Just from the above so we are censoring what the machine is doing and trying to understand then what's happening below. We have one initiative with the drill bit developer actually, that they have some measurement we are now installing to get information from the bit as well.
Yuri?
How much does it cost to drill 2 kilometers deep borehole?
Sorry?
How much does it cost to drill 2 kilometers deep borehole?
How much does it cost? The target would be, I was just counting, that if you think about, if we go back to here, that you should be able to replace 60 normal wells with that one. If we can count 10,000 euros per each 300 well, it should be 600,000. So then it would be about the same. Now it's not. It's not yet competitive. So if you compare this to 60 normal 300 wells, it still costs, and probably it will cost always a little bit more, because now the advantages come that you have smaller space, you have other things. But the market price, what I heard, is around 1 million, what you can charge for one of these holes. But
Euro.
yes. we are not that advanced yet. But I don't know the exact figures, but just the ballpark.
Okay. Thank you very much again, Samuli.